I actually met Jared, I think at the Jackalope. Well, no, that's when I really got to know you. He was my student at the DFIR Summit a few years ago. Really got to know the real Jared at Jackalope. So Austin kind of takes us back. And I'm really excited for his talk. He's a brilliant mobile researcher, and he's finally spreading the goodness back into the DFIR community. So go ahead, Jared.
All right. Thank you very much, Heather. Make sure I can drive here.
Looks
Okay,
great.
good to go. All right, thank you. So yeah, my name is Jared Barnhart, and I appreciate the opportunity to be able to do a talk here at the SANS Summit. Thank you, Heather, for the the kind words. And yeah, we meeting Heather in Austin and the Jackalope, all great memories. But just very briefly about myself, I'm a retired police officer from Maryland, and now I'm a forensic engineer for Parsons Corporation, completely focused on mobile research. So this talk today is going to be about some of the artifacts that are revealed to us in iOS 13, and partly in thanks to the checkmate exploit or vulnerability that was discovered last year. So this tweet went out last year, last September, and it sort of changed the culture for iOS research, jailbreaking, forensics altogether. The part that I want to focus on here is that this exploit affects hundreds of millions of iDevices. So we spent a lot of time looking into third-party applications and looking into all sorts of other things about our devices. But hundreds of millions of devices on the same operating system essentially have hundreds of millions of the same native files, the same directories and the same databases and things that we should be excellent at. And if we're not excellent at them, then I feel like we're sort of missing the boat. So when this was released, it was announced sort of right after the iOS 13 release. Not iOS 13's fault at all. It's a vulnerability that affected devices going way back. It's great for us in that we don't have to necessarily hyper-focus on iOS versioning anymore and check and pray and hope for a jailbreak so you can continue certain research and constantly shuffling around your versions and hoping that you get a jailbreak at the right time. We have almost immediate jailbreak access, and that really gives us access to the full file system, which gives us access to those native files. This talk is not about checkmate, but it sort of pivots from that to the access that we have. Mattia did a talk that was recorded that I mentioned here, but this is really great for us. So now that we have the access and lots of people have the ability, I'm encouraging everyone to go all in on native artifacts. If there's something you're interested in, if you look at your device and you ever wonder, how is Apple doing that? How does it know that I really am about to drive to that place? It's in a file. It's in there somewhere. So I encourage you to figure out where, figure out why. Okay, and I threw this quote in there just trying to be comical, but I have been doing research for a little while now, and what's difficult is to put yourself out there. And I figured there's no better place to start than a SANS DFIR Summit with tens of thousands of people signed up. Seemed like a good starting point. So here I am, sort of putting myself out there and sharing some research with the community. What this does for us is it allows full access, and it's pretty cheap. So for the cost of an iPhone 10, which is just a couple $100, and assuming that you have some sort of machine that can interact with the device, you can do your own testing and verification. Please don't take anything that I give you here today and say it's absolutely correct. There's no doubt about it because Jared said it. Test it, verify. And I'm going to show you some really interesting things and then say there's caveats to that being correct. All right. So let's get right into it. There's sort of 4 artifacts that I'm going to try to get through here today. My list was like 8, and 4 is even packed. We could talk about the photos for a full few hours if we needed to. But the first one we're going to talk about is the photos on your iOS device, but specific to the facial recognition feature. So I'm going to sort of build from taking a photo and walk you through the point where it says that photo has this person in it. From there, we'll talk about recoverable deleted images on iOS. And this is just sort of an interesting artifact that I wanted to point out because I didn't know about it until very recently. The third one is the personalization portrait, which it's a beast, and it's weird, and it's constantly changing. It's extremely challenging. I spent a full day just writing queries that failed on that thing because it's just difficult. And then the last one that I'm going to do is a file called 3bars, which allows us to do some Wi-Fi location tracking. So let's dive right into the photos analysis. So I'm going to sort of build from the point where you take one photo and then show some of the processes and analysis that happen in the background and walk you through to where you're seeing it in your nice gallery on your device. So when you open, if you're an iPhone user, you open that Photos application, there's a lot there. It's not just a basic repository of photos and videos anymore. It's intelligent. There's obviously analysis that's happening. It's making smart categories. It's building memories for you. It is telling you a certain person is in a photo. And of course, the location data is something that we always cling to. You're able to keyword search. So you type dog and somehow it produces photos that have dogs in it, right? So I'm gonna break apart little pieces of that and hopefully make a little bit of sense or give you something to do more work on. So when you take a photo, right? This is just me pressing the button, and the file system that I was monitoring at the time just runs with changes. And then I close the app and it runs with changes. And depending on if you have Cloud Photo Library turned on and some of those other things will depend on exactly what file system changes are happening. But at the end of the day, you take a photo and it writes to a directory. Okay, very, very simple. All right, you can change some settings and make it a little bit different, but at the end of the day, you wrote a file, right? Easy. So let's get into the good stuff. So when I go into my photos and I search, like in the top left of the screen there, you see I just typed the letter G and immediately it populates Green Bay, another location. In the next one down, you see garment, grown up, grass. Well, yeah, that picture is of a dog and the dog is laying in a bunch of grass. So how's that happening? Moving over, I searched J and it did some other things. And then on the far right, I did SAN. And it picked up some photos that are sourced back by the location of San Francisco, but then it also found Santa Claus. So how does it know it's Santa Claus, right? Like it's really interesting, a lot of analysis and a lot of potential here. So the first piece that I want to talk about is the media analysis.db SQLite database file. This database is essentially grading and scoring and producing results for all the photos that are in your library. So once this analysis happens, it will determine if there's a likelihood that there's a human in it, if there's a likelihood that there's a face in the photo, potentially if there's a pet, if it's a high quality photo, or if it's blurry, things like that. When we look at the results table within this database, on the left side, you see asset ID and you see the number 3. That number 3 is one file. So for that one file, there were results of type 1, type 2, type 4, type 5, 6, 7, 9, 10. Okay. For each one of those results type, there's a blob. The blob is a binary plist. So when we take those results type numbers and look at the blobs, we can sort of figure out what that file that is being analyzed potentially contains just from here. So I took the blob and I saved it out as a plist, printed the plist as a text file, and you can see at the bottom with the red star, it says attributes, face bounds, face pose, face position, face quality. So whatever file that was number 3, probably has a face in it because this result is there. So then I repeated that process for all the plists that I have on my device. Some of those I didn't have data for. I'm not sure what that possibly is, but I didn't have data for some. And I sort of broke out a generic description of what a lot of those results types are, and then built it into a really big, ugly query. If you're awesome at SQL queries, feel free to fix this, but it works. So there it is. And it just simply breaks apart the different results types. When you look at the results types, you can then sort it to a certain type. So just show me the assets that have been analyzed that have attributes of human bounds or confidence, so that probably have a human in them. The local identifier that you see on the left side is going to match up to the unique identifier listed for the photos in the photos.sqlite database. So this database is doing its own work and doing its own analysis, but it's pushing out information to the photos.sqlite. So how often is this happening? When I took a look at this table, it had happened 2,200, or it had looked at 2,200 files that day. So it's a constant churn of your data to, I guess, come up with what's best. You know, how many times do you take 5 photos at one time and one of them is truly the best? Circle around a year later and they're showing you the memories from that day. They tend to show you the good one, right? So I think that's what's happening here. But how does the keyword search work? So there's a different file called psi.sqlite. And what this file is doing is it is essentially creating strings that equal objects that are found in your photos. This is not user generated in that the user isn't necessarily typing and creating strings, but instead, when I take a photo of a vehicle, it associates that photo with having a vehicle in it. So it finds the object. So when you search dog, it finds the photos with dogs, or potentially it misses and you don't get all the returns for dogs. But when we dig into the file, looking specifically at the word embedding table, it has a bunch of blob data, words and extended words. Just simply printing that out to a CSV, we can see that they're sort of building out subcategories that point back to a major category. So like an anniversary is a type of celebration, and probably like a birthday would be a type of celebration. So that when you search for German Shepherd, it searches for dog, type of a thing. All right, but these values are not just pre-populated and filled up when you buy a device. It adds new values as you use your device and as you take photos that have different types of objects that it knows how to recognize. So it is indicative, at least in part, of user activity, but you're relying on Apple's analysis of photos and telling you what objects are in them. So just be careful. When I searched for G in that screenshot before, it populated Green Bay, and that isn't super exciting because I have an album that I named Green Bay. But when I tried to find Green Bay, it got really interesting because I took my device to Green Bay, Wisconsin one time, and I went to an NFL football game where the Green Bay Packers played the Miami Dolphins. When I found Green Bay in the groups table here, on the right side, you can see Green Bay Packers versus Miami Dolphins. Now, sure, Apple can figure out that my device is at an NFL stadium and somehow map in, you know, what game was played that day. But I also took some photos that had in the background people wearing certain types of jerseys for both teams. I don't know what's happening specifically, but it's very interesting to me that they helped me out and added in here Green Bay Packers versus Miami Dolphins. And then it's going to get creepy, so just stand by, okay? So photos.sqlite, this is an old topic. People talk about it all the time. You could have a whole day of talk on this one file. It's a SQLite database, and on mine, it's over 300 megs in size. It has potential to tell you when a stranger was creeping on your baby, so just stick by on that. Here's just a screenshot showing you the overall look of the database, but it's huge, tons of tables, tons of columns. You can get lost in this thing and spend weeks. It's great, but just be careful, don't get lost. We're gonna focus on the faces. So the Z detected face table within the photos.sqlite has certain values that indicate age, hair color, baldness, things like that, okay? Measurements of the face and a person identifier. So in here, I was able to take pieces of it. I didn't tackle hair color because it seemed like it would be extremely difficult to come up with what they were doing with that. But I tried to do most of the rest of them. Age is a little bit weird. Sometimes when I have really short hair and not quarantine hair, it thinks I'm a kid. Other times it rates me as an adult. But it's really neat what it does with age, gender, eyeglasses, and things like that. So the person association that's happening from those photos, so on the last one in the detected face, it has a value that says potentially there's a person here. When you go look at the Z person table, it's essentially tracking how many times that face has been seen. So in mine, my immediate family, close friends, it has names associated with them. But other people, so when I take a photo that is of, one specifically was my brother and holding my kid, but right behind them was my uncle who was bald. It populated in the analysis of that photo that there was a bald male that it doesn't know, there was no name, and he got a unique identifier. When it has the same person that it thinks, but it doesn't know who it is, you'll see a value continue to count up saying, we have this face 30 couple times, but we don't know who it is yet. At some point, it has a way to convert itself to a known person and points all of those unique identifiers to one with a name. If it is a known person, there's potential to get contact information from the binary plist blob in the contact matching dictionary column that you see here on your screen. So in this one, I was able to find my mother-in-law's first name, last name, and phone number being sourced from the contacts associated with the photo that was taken of my mother-in-law. So this is a query, again, focused on faces. So at the bottom right of your screen, it says where Z face area points is greater than 0. What I found is that face area points having a positive value indicated that faces have been found in the photo. When you see the baby toddler part on the left side, or child, young adult, be careful with that. It's not exactly right. Same with facial hair. My kid's wearing a hat that has sort of like a furry flaps down the cheeks can make facial hair. I've seen shadows make facial hair. The gender can be wrong. But when it works, and it works a lot, and it's really good at finding faces, it's pretty neat. So in this photo, I chopped off a lot of the results, but I focused on just a few. This is a photo of me and my 2 daughters. You can see the file name in the list above is all the same file. So in this file, they found 3 people. Those 3 people are an adult and 2 babies or toddlers, as I estimated it. Gender, male, and 2 females. The name, me, and it had my daughter's names. And then face count. It says it sees me 387 times, and I know that there's a lot of photos of me that it hasn't been able to identify as being me yet. And then you can tell which one is my first kid because it's the one with 1,700 face showings, and the second kid, well, you know how second kids go. Glasses type, I'm wearing sunglasses. It will list out no glasses, eyeglasses, or sunglasses. And then facial hair, again, can be tricky. But then there was this one where it's like, hey, there's a stranger looking at my baby. So I took the picture of my kid, and when I ran this, I saw that there was an adult showing, and it was Susie Colbert, the ESPN analyst, in the background of the photo. So just really interesting that it's able to say, hey, we see a female and a baby, and it picks out that sort of blurry, not great woman that's standing behind the baby. So let's get into recoverable deleted images. And I'll start by saying unallocated space on iOS devices is encrypted. It's not something that we can recover. Okay, so this is the caveat to that. Typically, when we deal with recovering deleted photos on mobile devices, we are carving them out of unallocated space. Now, just very basic and quickly on unallocated space. If you take a photo and it writes into your file system, it's allocated. The file system can track it. It can recall it whenever you need to see it. When you delete it, and you really delete it, not send it to the recently deleted folder, the data where that file existed is potentially still there. It's just no longer allocated or tracked by the file system. So if in that moment you were able to grab a physical extraction of the entire flash memory, you would get that unallocated space, and then we could potentially carve out the whole file or pieces of your picture file. On the iOS device, that area outside of the allocated space is encrypted. So we can't recover deleted photos except for this. So this was brought to my attention by an old coworker of mine, Sergeant Ryan Sox, shout out to him. It's not necessarily new. When I mentioned this to Heather, she seemed to know about it, but I hadn't heard of it, and I think it's really interesting, so I threw it in here. So within your messaging application on iOS, at the top, you're going to have some sort of visual indicator of who you're talking to, the contact name, photo, whatever it is. If you press that, and there's a little drop down, there's a small eye in a circle that opens information about that contact and the thread of messaging that you have going with them. When you do that, if you have media files that are in that thread, it shows them to you. If it shows them to you, it is rewriting those files to a secondary location. And what we found is that when you delete the file from the thread, it does not touch the secondary location, so they persist through the deletion. So I'll walk you through it. Brand new device, set up for testing, and I started an iMessage thread essentially with myself on a second test device. Very basic. The path, just to go back here, is our mobile SMS previews search directory. So when I go look for it, it's just not there. It doesn't exist. Brand new device. I've never touched the eye. This directory isn't there yet. So then I sent a photo from one device to the other. Upon doing that, I was monitoring the directory, and it showed me that there was a preview image that was populated. It's pink. That's a whole other problem and discussion, but there's still no search directory that was created. So then I went back in and monitored the file system while pressing that little I. And when I did that, it shows me the picture in the information screen. On the right, you can see that the previews and search directory was just then created. So then I checked the previews search directory, and now it has a photo search section at, and then a GUID.png. When you look at that, it is the image file. Great, nothing crazy. Then I went back in and deleted it. So imagine someone sent you a photo that you wanted for a time, or you didn't want at all, and then you delete it. But at some point you pressed the I, whether to recall all the pictures that have been sent, whatever the reason may be. When I delete this photo, and you can see it's clearly gone, and there's no image in the information pane anymore, it's still able to be pulled from the directory. Then I went back and I deleted the entire thread. So not just taking the photo and removing it from the thread, but there was no messaging threads at all, and it's still here. Attribution is difficult, but I'll take that deleted photo all day, okay? All right, moving on to personalization portrait. So this thing is a beast, and it's challenging, but it also holds a ton of data. So there's the path to it at the top, and this directory showed up on iOS 12, but it didn't have this file in it. When iOS 13 came up and I started to review it, I saw that this file existed, and it had some interesting information in it. The name personalization makes me think this is helping out with all the stuff that I want my phone to do for me, that I'm happy as a consumer. When I swipe and look at my widgets, and it's just the news that I want to see. And when I get in my car and plug it in at a certain time of day, and it knows where I'm about to navigate to, like the personalized piece. When I open my photos and it has the memories ready for me from a year ago when I was in Las Vegas, that we all wish we were somewhere like that now. But this is constantly churning. I implore you to be careful, because the timestamps on this are when the personalization analysis ran most of the time. So it checks and says, let's look at the photos and see what's upcoming for a memory, or let's see where this great photos from a year ago. And then it timestamps, potentially right now, photos from a year ago. Now the photo SQLite isn't going to have that problem. But if you get in here and be like, oh, great, it was 3 days ago and they took these pictures, you're probably wrong, because it's probably a memory or something that was being pulled back. So be careful. But the interesting part about this is that it comes out in an iTunes backup. And that's exciting because it has routine data in it, which we typically only see in our full file systems with our routine D folder. So with our routine data is where we see a lot of the significant location type of stuff, the places that you enter and exit most frequently. And Sarah Edwards has a bunch of work done on the local and cloud SQLite files. That's awesome. But it's essentially the same type of data. And with these, you can see the binary P lists that show you when it was entered, when it was exited, or the expiration date for these locations. When you take those specific pieces and throw it into a map, I can tell you that my device absolutely was at all those places, but you know, it wasn't there on the time that you see. That's when this analysis occurred. But we're seeing data here coming from a backup file that potentially we wouldn't be able to see otherwise. So I like it. And then here's a query that produced the results that you just saw. I'm just throwing those in there for reference later. Another interesting piece about this is that it's grabbing out third-party data as well. So I had installed the Crew messaging application, which is sort of like a Slack, and I set a notification to only give me, or I set a geofence to only give me notifications and include me in conversations when I am at work. Well, it pulled out the correct address and the name of that group that I created from that third-party app, and it was listing it here in the location record. So that's super interesting. We see other files referencing third-party apps all the time, but to actually have content from the third-party app pulled within here is quite interesting. One other table in this personalization portrait that I wanted to point out is this NE, which I think it means name records table. So in this example, I opened a Safari tab and I did a couple searches just trying to populate data. And then I filtered this down to just the Safari content. And you can see the names that it grabbed out of the article that I was on. I sort of underlined a few of them so they jump out at you. But it is tracking the names or the names of objects or people or places or things. And it's tracking how many times they occur in the source. Interesting. But then I found this other piece where I had been in an SMS text message conversation with my uncle. In my phone, my uncle is saved as Rodney and then his last name, and it's not the same as mine. In the actual text that I sent to him, I called him Uncle Rodney. Well, this database pulled out Uncle Rodney and wrote his last name with it. Why? I have no idea. But it's interesting that it's learning that name and pulling it aside to associate it to something later, I think, and a query for that. The last piece of this that I'm going to cover for this talk, and again, this thing's a beast and it's weird and it's constantly changing, is this TP records table, which I think means topic. In here, one piece of this, and you can sort of join this to a bunch of other tables and make it interesting. But one piece of this that I picked out was that you essentially can track back the iOS version history for the device back to, so for my device, it was back when I got it. So it was able to track back to when I was on iOS 13 as a start. And then by joining in a different date and time from another table, I can essentially benchmark when I upgraded my device. It also is able to pull in my cloud connected Mac artifacts. So by running the query, you potentially can pull out a rough estimate. You see these go back to 2019, a rough estimate of when the device was on certain versions. And there's some other files that can do this for us as well, but it's just interesting that this piece is built in and you can join that to other data as you work through this file. I already wrote a blog article on this that Sarah hosted for me on macforensics.com, but this thing is extremely challenging, but it's also extremely interesting. The last artifact that I want to discuss is the 3 bars. How many? Apparently just 3. So the screenshot that you see here is something that I was lucky enough to capture, and you may have, when you see that, think, yeah, I see that pop up on my device. Well, that started in iOS 13. And when it's sort of as the new iOS versions release and those new things like sent by Siri and those little things that are just different about the new version, those of us who do this type of research sort of obsess on figuring out what happened and why. Well, this sort of drove me nuts a little bit, that they were offering me Wi-Fi. Okay, great. But you can see that I have great LTE service when they're offering me Wi-Fi. So why are they doing this and how? I don't know for sure, but I have a pretty good guess. So here's the path to a file called 3bars.sqlite. And it tends to be commercial, not residential. But what this file is doing is it's providing the geocoordinates and BSS IDs for wireless access points, roughly where your phone is. I did take a test device and went for a drive that is not internet connected, and it did not populate any data even after it was reconnected to the internet on where it had been. So essentially what's happening here is if I picked my phone up right now and drove an hour to my west, whenever I get to my destination, it's going to populate information about these Wi-Fi networks that are available that are near me. So you're able to use that to somewhat track locations. But when you look at the query that's here and then the results, it's giving you the time, and it tends to be like a global time. Like when I got to that new place, it's like, all right, he's here and populate. But it rates the access points based on a popularity score. So there's potentially some research that could be done there to figure out the rating. I saw like a McDonald's at a 31 and a high school at a 588. I'm not sure exactly how they're scoring it, maybe by how many devices show up there, I don't know. But does that wireless network have a captive login? Is tracked here. Does it move? Things like that. But it's giving you the coordinates of where it is, and it's giving you the BSS ID. Now, what's interesting about that is it's not necessarily right exactly where you are. So when I went from where I live up in the top left down to where I don't live, it wrote some places that were really, really close to where I actually was. But apply that to sort of, I guess, security locations. And we'll talk about that more in just a second. But using this as location tracking, probably not. Can you? Yeah, roughly. In the top left, you have the personalization portrait and those routine D points that are definitely where I was. I was there. On the right, you see just 3 bars, just this. And it's like, yeah, I also was vaguely at those places. If you zoom in, it's not that great. And then compare those two in the middle to adding in the cache.sqlite file. And you can see how granular and how perfect that cache.sqlite seems to be compared to these other two. But by looking at how accurate that is, does it make these other two wrong or also right in their own ways? I think they're right in their own ways, and it's interesting. So for this specific file, the question I want to ask you is, do you care? If you have a fence or a gate, and behind that gate is things that you expect people's devices can't reach, I challenge you to take a look at this file, because there is potential that when that device gets close to, and by close to it, in some instances I saw miles, close to a location, it potentially is beaconing out your BSS IDs, where they are, and some other basic information about them. And again, I challenge you, do you care? And I will end with that. So I want to express huge thanks to Sarah Edwards, great friend and mentor of mine, and then everyone else in this list, Heather Briggs, Josh Hickman for putting out the public images, and then all those other resources that I use all the time. And so if this has, sparked any interest for you, please reach out to me. My Twitter handle's there. I'm going to post some follow-up stuff to this on Sarah's website. She's been gracious enough to offer to host some stuff. But just if you're feeling lucky, let's go all in and let's figure out these iOS devices.